Okay. Hello, everyone. Today we have our core protocol sync. We have more and more people, so we probably should be a little bit more brief going forward. We'll share updates on the core protocol side and our plans for the future. I guess, Wolfgang, let's start with you, if you need to leave earlier.
Okay, I don't have a significant contribution this week, but Nazar, you have been working on the OpenCL pull request. I was reviewing it, and tomorrow I will do some additional tests on top of what you did. This will be my contribution to core protocol. Other than that, I don't have any news.
Okay. Depending on your load, we also discussed that we probably want to upgrade the CUDA implementation with the changes that Supranational did. Like to maybe unify the CUDA file and make it reusable.
Yeah.
So that will be probably like a midterm feature thing to work on if you have time. Okay, Ivan, let's continue with you.
Quick update or quick comment on that. Yeah, I think what your workload is going to look like for the next month or so, Oskin, is going to be finalizing the remaining bugs on the desktop farmer, which I'm guessing is going to take about 1 or 2 weeks, and then trying to get the CUDA integration, or sorry, the GPU integration done. I'm hoping that we can dust off the old article that we wrote and just update that with the new info and go ahead and get that published. And then by about that point, I think Ivan will have the distributed farming working, and then we can trickle those changes into the new desktop farmer. And yeah, and then we'll be set up for success at that point. So it'll be a little bit of a switch back and forth over the next month or so.
Sounds good.
Okay, let me share screen. Can you see it?
Not yet.
Is it working right now? Okay, thanks. Yep. So basically, during the last week, I was working on the partial replica support. So right now it's going through the last round of the review by Nazar. So yeah, the main change introduced by the PR was that we, in order to write the pieces, right now we will have the limited storage, right? As the replica might be partial, we might accidentally exceed the storage. So right now, writing pieces in the plot for the disk looks like this.
So sorry to interrupt, but can you make it a bit bigger?
Oh yeah, sure, of course. It's better.
Yeah, thank you.
So right now it works like this. If we can, we just try to write pieces to the end of the file. So basically, we just check how many pieces can be append at the end of the file. So and after that, we try to overwrite pieces individually if we exceeded the plot size itself. So yeah. Also, here's somewhat important check that our piece is in range of our plot itself. So there is a case when we basically do not need to store the piece itself because its index is out of range of our backup range of the plot. So otherwise, if this check passes, we just remove the furthest piece index and overwrite its space using the new piece. So yeah, it works like this right now. And apart from updating the plot, we also need to actually update the commitments for the solution checking. So right now it works as follows. We basically print some special case yeah, which is related to that emitted pieces when we basically went out of range of our backup plot. So yeah, we in this case we need to check that all that the new pieces are actually within our backup ring. So and in this case we I mean after that we just encode all of the pieces and try to write on the plot. We will try to write it on the plot, and the plot itself will remove the all of the new offsets of the of each individual piece which we wrote on the disk, and also it will give us the pieces which were overwritten, as we need to remove those um, from the commitments, because yeah, we no longer have those and we won't be able to retrieve it from the plot itself. So beforehand we just appended to the commitments because the commitments will never change. I mean, they will be just swapped like on the salt changing. So yeah, and right now we just remove the old pieces and update the new ones, append the new ones.
Can I ask a question?
Yeah, sure.
This is an implementation detail, so nothing on the algorithm side. How does remove the furthest piece function works?
Oh, yeah, sure, yeah.
Like, are you storing a cache for finding the furthest one, or you are just queuing all the pieces?
It works as follows. I mean, at first I didn't have the cache here, but right now I do. But basically, it works like this. We store the we basically store the offsets. We have the map from this index hash to piece offset, and basically instead of storing the this index hash itself, we store it using the distance itself from our identity to this piece index hash. So by that we optimize this kind of case, because right now if we want to remove the furthest offset, we just can use the features from the RocksDB. Like RocksDB has all the keys sorted by the yeah.
Okay, so it's stored in a sorted way. Okay.
Yeah. And basically, by storing it using the distance, we can just query the last one, and yeah, it will just work. I guess that's it from my side.
Ivan, is it doing all this like swapping on initial plotting as well, or just on the updates?
There is no difference.
Okay, so if we're doing initial plotting and we're everything is within the size of our ring, does this incur any additional overhead?
No. All of that code will just run using the empty arrays. So yeah, no changes on that.
What do you mean by empty arrays?
I mean, we at the moment of writing the piece on the disk, the function write many, it just returns the to arrays all pieces which were overwritten and new offsets basically. So the old pieces which were overwritten, this kind of array, it will be empty. Yeah, and no work will be done.
Okay. Have you confirmed that with any benchmarking to see if it changes the plotting speed with the before and after code?
No, I can add the benchmark after merging VPR if it's fine.
There should be benchmarks in there already. I think you just have to run like the CPU benchmarking.
Okay. I didn't check that. Okay.
I don't think we have it.
Oh, did we check that out?
It wasn't there in the first place. What we had when we had Spartan implementation, we were just printing the plotting speed. I think at the end, after the plotting is done. So we were aware like of the performance, and when we changed it to like plot individual pieces, we actually took that out, and we didn't have standalone benchmark, I don't think.
Okay. Okay, so we don't even have a way to compare before and after right now.
I think we can find a way. We can just do some add some instrumentation and measure it.
Yeah, I would like to just confirm. I mean, I know it should work that way, but there's a lot of things that we've assumed should work that we've learned actually don't work out the way we expect.
It will definitely be a little bit slower because it does more. Previously, some things were just implicit, so it didn't do some checks, it didn't return some values. It was like all sequential or contiguous in terms of number line. Right now, it's not, so it returned a vector of things that were plotted. So that will be less efficient, but yeah.
It's not clear by what degree. Hopefully negligible.
Should be negligible.
Okay, yeah, let's confirm that with some benching.
Sure, yeah. I mean, I have one question about that. I guess the interesting code path, after that PR is merged, will be benchmarking the basically overwriting the piece itself, but we couldn't compare overwriting the piece itself with the cases before because
I don't think it matters too much. That will be amortized over a very long time.
Oh, okay.
It shouldn't be hot path.
Okay then. Sure.
That's why in review I mentioned that this typical case when we start and we want to fill it up, we should really optimize it as much as possible, but the rest is not that important.
Okay then. Yeah, I can just add the benchmark with the new PR.
I feel like you need to create it by branching off the main branch. Otherwise, you cannot compare before and after.
Yeah. I mean, I can return backwards in the history before even merging the first PR of mine with the.
Okay, I think you'll figure it out.
Yeah, of course.
Any other questions, comments?
One question on right now, if we have enough space to support a full block, we do up until that point. Do we already have a code path where it automatically migrates from full chain to a replica section of it once the size of whatever we are plotting is more than the blockchain?
That's exactly what is done by this PR.
Okay.
Yeah.
Okay.
So it just fills up, and then once it's full, it will start evicting all pieces.
It will start to evict. Okay, cool. Okay, cool. Makes sense.
Yeah, and Yvonne, for the benching, just to be clear, it should just be something like megabytes per second, of plotting speed. Like if we want to plot 1 gigabyte, for example, it should be before it was, on this machine with the exact same settings, it was 30 megabytes per second, over a 1 gigabyte plot, and now it's 28 megabytes per second, something like that.
Yeah, that will also be useful when we add OpenCL, and we can compare CPU versus CUDA versus OpenCL, and we can compare how much overhead we have with CUDA when we run it through OpenCL instead of directly, and all kinds of things like that, for different devices.
That would be handy.
Yeah.
This is something we were in for a long time.
Yeah, it should be like 5 minutes of code. It should be a very simple time check. So don't overthink this problem. I think it was 8 or 9 lines of code before in a previous implementation.
Yeah, I don't think we need something like criterion, something just measure the time for plotting half a gigabyte or a gigabyte and take measure how much time it took.
Okay, yeah.
Cool. Red, do you have something to share?
Not a lot that I can contribute to Protocol Sync this week. I just got off a call with Sergey. I got just talking about the palette feeds that he's working on. I think I'm gonna start working on the justification part of it, at least on the runtime side. I think that's pretty clear, and hopefully I have some more news to share next week.
Awesome. Makes sense to me.
Okay, and who do you have left to sync with on the protocol team?
Lushank on Thursday, Ozgun tomorrow. I couldn't find I'm going to reach out to Ivan. I want to get everything done this week, Jeremiah. I have a clear idea as to where protocol everything sits. I just wanted to get up to speed if I missed anything in the between the commits. But apart from that, I think I'm pretty much set. I can get started on the runtime.
Okay, Luchan, it's your turn.
Okay, sure. Let me share my screen. Oops, an error occurred. Sorry. Let me try that one. Okay, so can you see my screen now?
Yep.
Okay, so last week I actually have two PRs get merged to the Subspace repo. The first one is actually some preliminary changes for this fraud proof creation. Nothing important there. So I just start with this one. So this one is about implementing the fraud proof creation on an executor. And this implementation includes all phases of this execution, including the finalize block, initialize block, and any specific extrinsic execution. This verified against an executor node. So the verification on the primary node is still a work in progress. Yeah, it's not yet done. So basically we can check out this test to verify it really works as expected. Okay, so I believe this one. Okay, the test. Okay, this one, the test. So in this test, I created 3 transfer extrinsics, just simple transfers. And I firstly to verify it's the finalized block proof creation and the verification should work. So okay. So okay, this one. And special points about this initialized block for the proof creation is about this new header, which is the argument for this initialize block function. When you initialize the block initially, when the block was created at the first place, the header is actually empty, right? So we cannot use the header after after the block was applied, because there is a field state root. It's different, like before this block is applied, and one is initially created, so we cannot
The
use.
question there, shouldn't we populate the state root with the state root after the previous block? Should it really be zeros?
You mean the state root before initialized block?
Yeah.
Actually, it's the state root of parent block, so we don't have to.
Right. I mean, should we create that like empty header with the state root of the parent block instead of zeros?
Nope. It doesn't have the header doesn't have the like state root of parent block.
Right. I
The
mean,
header has
it does have state root of the current block, but before we did anything, the state root of the current block as of right now is the same as of the parent because we didn't do anything yet.
so let me put it this way. The argument and this method is exactly same with the block was created initially. So if we want to like replicate the initialized block execution, this is the way. You
Okay, so
use
just mimics what Substrate does.
Yes. To exactly replicate all the like execution environment with the same method, same code data, and the same state. So here is the exact like same code data when you initialize the block. So basically, to prove or to verify an execution, you have the method. Here is the method, right? The method, the code data, the code, the runtime code, and the state. That's everything you need to verify an execution, right?
Okay.
So if we want to like to prove the initialized like block that was done before, we have to like reproduce all the entire like environment like precisely. Okay. The another one I would like to mention is, okay, this block, this finalized block. The interesting thing is like this method, the final block, the finalized block runtime API, like has a return value, which is the newly created header, which already contains the state roots. So we don't have to like create a new runtime, new runtime API wrapper, like we did for the apply extrinsic and the initialize block. We just use this existing one, and we interpret the intent value as a header, and we extract the state root and the post state root. Yeah, and another thing I would like to mention is that's still a problem. I haven't like figured it out. It's this one actually. If you come out like some logs, the test will like behave differently. The test will feel like it was expected to return the like the post-state root, but in fact, it returns the pre-state root if you disable this log. I haven't figured out. So I'm still working on it, debugging this problem.
Is it really a problem, or is it just an unexpected behavior if we're consoling out? Does it actually change the execution of the fraud proof, like the verification?
I think it is a problem we have to figure it out.
Like in this case, potentially when we disable info logging, it will stop working, which is like doesn't make any sense.
Yeah.
Even parity is stumped on this one.
I'm guessing it's probably similar to the problem we had before. You remember the deterministic storage proof problem? I'm guessing it might be kind of that problem. Haven't confirmed this. Yeah, that's
okay. Are we at the mercy
updates.
of parity until they can tell us how to fix it?
I'll first to debug this on my own, and then I'll try to file issue or something. Yeah.
Okay, can you give us a recap, Li Cheng, or sorry, a summary at a high level of where we're at in sort of the roadmap or the implementation of decoupled execution, kind of what the next steps are, kind of what you see as the timeline right now?
Yes. So currently, forget about this, to do this problem. We have implemented the fraud proof creation, right? The next step will be the fraud proof verification. So that's the main problem. After that, the whole fraud proof is basically done.
Fraud proof verification on the primary node or the secondary?
Yes, on the primary node. Unless on the secondary node is already done.
Okay.
Yeah. So after that, I would say the fraud proof is basically finished.
Okay, and have you thought more about the implementation strategy for how to have the secondary runtime on the primary node?
As I have mentioned the last call, we can we have an already pretty clear approach to integrate the secondary runtime into the primary runtime. But I haven't think about the whole workflow about the secondary runtime upgrades. I haven't think about that.
Okay.
I have showed last time we simply mimics the primary runtime, we build an Wasm blob into the runtime directly. I remember Nazara said there could be section of Wasm or something like that, but I think mimicking the primary runtime blob would be easiest, I would think.
Okay.
Actually, right now, what I'm thinking is that we can probably have one crate which is consensus runtime, the other one is execution runtime, and have just runtime, which basically has two modules inside of it. Kind of namespace basically functions. And you can have different executive that runs the actual runtime calls. You can basically have different functions called from the outside for different runtimes, but it can be all in one bundle together. And you can have things like link time optimization over two things together.
Actually, I haven't I don't have a clear a larger vision about how these two runtimes work together. I don't have a clear vision about that.
Okay, we can maybe schedule a call this week
like-
to discuss this.
Yeah, sure. How many use cases will be necessary for these two runtimes combined together?
Well, we have like two features, right? We want to upgrade not only first primary but also secondary runtime, and we need to be able to call secondary runtime functions from the primary node, like for fraud-proof verification.
Yes.
Those are, I think, are like two overlapping use cases that we have.
So if that's the use case we can come up with for now, the primary runtime needs to call the secondary runtime to verify the fraud proof. If that is the one, I think I don't see much difficulty supporting that.
Well, I'm just thinking I'm not entirely clear on the drawbacks of having them separate or together. Like what would be the benefit and the drawback? What would be easier to upgrade, or what would be more efficient to upgrade because we don't need to upgrade the primary runtime if you didn't change it, or something like that, Like whether there is any meaningful difference.
Yes, makes sense. I personally take some time to think about this, all the cases, about the runtime upgrades, and then we can schedule a call and we discuss it.
Okay.
Yeah, and one thing to keep in mind is that the secondary runtime should only be upgraded if it's approved by the farmers. So the executors shouldn't be able to upgrade their runtime independently. So really, in some way, a runtime to the secondary upgrade is almost a runtime to the primary upgrade. Like they should maybe be thought of as similar.
Well, there is another dimension, or another level of depth to it, because the runtime upgrade will actually happen on the beacon chain. And everything else, all of the shards, including their secondary runtimes, has to follow. So it's three-step process for secondary runtime on some shard to upgrade.
Right. We don't want to talk about beacon chain and shards yet. We'll probably make everybody's head explode, like David's did yesterday. But yeah, fair. Okay. Yeah, and please invite me to that as well, Li Cheng. If we can try to have that later this week, like Thursday or Friday, that would be great. We do need to have this discussion before next week. Okay, cool. One other question, Li Cheng. So now that we have this fraud-proof implementation, does that mean that we have to, with the current build of Subspace, that we have to run an executor in order to run the farmer network, or is there a flag where we can run it without an executor? How does that play?
The executor is still an additional binary. We haven't merged the executor features into Subspace node, making it one binary. So you don't have to include any executor features to run a farmer or Subspace node right now.
That's actually something I would like to work on. I like these kinds of things.
Yes, I would like to work on after the fraud proof.
Okay, but we could run it where the farmers just trust the fraud proofs for now, just to test how it actually works with the farmers and the executors. If we assume that the execution is always done correctly because we're running one trusted executor right now, or a handful, I guess we can only run one at this point.
Yes, you can say. You can say so.
Okay.
But I haven't tested that. I haven't
You haven't-
do anything like about this to actually delegate the execution from farmer to the executor.
Well, it will produce empty blocks. Doesn't really matter if it does anything. Well, it needs to process some bundles.
Okay. And what is
But can we have empty bundles? Like with empty vector of transactions in it? Is it still a valid thing?
Yes, definitely. Yes, of course.
okay? So what? It's still not clear. I guess I thought when we merged this in, that was implementing this functionality. But we're merging it into a fork of Substrate or of our implementation right now, not into the primary releases that we're doing, or the master main branch.
Right now we have, for this decoupled execution, we have two executables. One is Subspace node and the other one is like Cirrus or like Parche collator or whatever it is
Right.
called right now.
Right.
So they are kind of like separate. You can run just Subspace node or you can run both.
Right.
And then we have execution separately. But it's like an optional
But
feature.
Oh, that's right, because we haven't actually separated. So we still have balances on the main chain. So we have this execution environment, but there's not actually any functionality in there yet. So it doesn't really matter. Okay.
Yeah.
Okay. So you
Yes,
can run
yes,
it without
yes.
it. You just won't get these bundles that are coming in. So if we run it, we'll just get some extra extrinsics, which will show up
Exactly.
in the primary chain, which will get validated, but there's really nothing to validate because there's nothing being done there. Okay.
Yes.
Makes sense now. Yeah, I think that would be great to do that sooner, like as soon as possible, to just get that like on our testnet to the point where we have one executor that's just there, that's like sending messages back and forth, and then like incrementally like start testing how that actually works and start incrementally upgrading, you know, the degree of trust and the degree of verification that can happen, and like migrate over, you know, balances from farmers to executors. Like we'll have like a roadmap to do that. But I think getting this code tested like in the wild sooner rather than later will be better to identify bugs and issues.
Yes, that was already on the list, but you know, the fraud proof is the top priority.
Yeah, but I mean, we could like, it seems like that's like low hanging fruit just to get this to the point where we can start testing it, and then, you know, get that in our test environment, and then we can continue working on the fraud proof. Like, I don't imagine it would be that much work just to deploy this, you know, to run like one executor. It's more of a DevOps thing, right? Than like changing the code or like implementation at this point. Maybe we can talk about that in the call later this week. But I'm just saying, I think it sounds like we're at a stage now where we can actually start testing this at some level.
Okay.
Okay, thanks, Licheng. That's all the questions I had.
Yeah, that's all.
Anything else? All right, let me share my things then. This is the one.
Yeah.
Okay. So there were, I think, two big things happening last week. Substrate upgrade is not really very interesting. It was mostly mechanical, but there were some changes to the way time slots are handled in one of the places. It was actually a simplification on Substrate side, thankfully. The other one was this fix for the plot test. We had to comment out one of the things after Ivan introduced new features. And I decided to take an opportunity and actually simplify it a little bit. So previously we had several different kinds of requests for like internal implementation of the plot. read and writes, and we prioritized reads over writes. That's why it was separated. But then we didn't really know, like, it's not asynchronous, so we don't really have a way to like join them and wait for either of those to return the message. So we had another channel on top, and we had like 3 channels total. It was really awkward. So the first step to simplify it, I basically combined them into one, still called read request here, but basically all of the commands are together here. So that was the first step. Then I added notion of priority. So instead of having different kinds of requests, we have the same kind of request, but each command can be prioritized, and we can even have read requests of different priority now. So some reads can be less prioritized than the others. So basically high and low priority, and then it just sends commands with different priority but doesn't account for them in any way yet. Then the third pull request commit is to actually take that into account. So basically it has this kind of queue of different requests which are low priority, and it goes through the channel, reads messages, and tries to process all of the high priority requests first. If it's low priority, just puts them into queue. However, once it loops over everything, and there is a new channel read at the very end to try and read more and more and more until it's empty, then we will process just one low priority request and then continue the loop. Continue this like smaller loop, not the channel read loop. So basically, we will process read requests as often as possible, and we'll sprinkle write requests in between, or like low priority requests in between. And then I finally implemented the protection for the database closing. So when we drop the plot instance, it will actually wait for all of the requests to finish. It will close all of the databases, like RocksDB database, the plot file, everything, and only then it will return from drop. So we can uncomment our test, and it will actually pass, because by the time we drop the plot in here, everything is synced, everything on disk. We can open it again. There is no log conflict. So that was an interesting thing that resulted in simplified implementation overall. Any questions on this?
So do we still consider the write request to be the low priority and read to be still the higher priority, or are we already picking some of the specified read as well, lower priority as well?
Still just high priority reads, low priority writes, but now we have infrastructure to actually make low priority reads as well, if we need. So something like solving for a challenge is high priority, and something like recommitting the database is low priority, honestly. And we now have a way to distinguish them without duplicating the code. Another big thing was OpenCL refactoring. Basically, we had an implementation. This should actually be OpenCL. This is implementation from Supranational. They did our OpenCL version of the codec. It wasn't very safe. GitHub is buggy today. And I did a bunch of refactoring to basically make it safe. Overall, the way it looks like right now is we had a bunch of functions before, and now we have this encoder. We can instantiate it with an optional parameter, which is the batch size. So we need to specify, or we can specify how many pieces we will basically encode in terms of bytes, and how many layers we'll use. That is useful for currently one reason. There might potentially be a second one. So the primary reason is in case we have multiple GPUs, it will actually figure out how to best distribute all of these pieces across different GPUs depending on their capabilities. It will do something like a quick benchmark on all of the GPUs, and then it will estimate how performant they are, and it will assign different score or like priority for different GPUs, and it will split the load between them so that they finish all approximately at the same time, and they can do more on multiple GPUs, even though they can be like from different vendors. So you can use NVIDIA, AMD, Intel, and CPU at the same time. Like CPU is for like remainder if it doesn't fit the batch size. So that is like an optional thing. It will actually be recalibrated every time we encode if this encoding doesn't match the batch size. So that's why one of the tests is having this parameter, the other one doesn't. Just like the matter of when we do this calibration during instantiation or later during encoding. So ideally, we'll use the same batch size all the time, and then we don't have to do this recalibration in the runtime. The second potential thing, which is currently, as of this pull request, is commented out. This is the part of it. There is a codec part of it. There are some tests commented out, which are related to pinned memory, which basically makes NVIDIA encoding more efficient. I just don't know by how much. If you have to do it, then this batch size will also do allocation of pin memory. And it will do reallocation when that changes. It just makes API very cumbersome to use and ugly. I want to make sure it's more than 1%, let's say, performance difference, because we still have good API which uses everything as it should on NVIDIA GPU directly. So maybe we can avoid pin memory. Right now, it's just commented out with the same to-do message in all places where it's relevant. And obviously, the benchmark is also updated for OpenCL. The OpenCL benchmark uses the codec now, and it has the batch size explicitly because we want to initialize it before the benchmark run, otherwise it will skew our results. One of the useful things I've added is actually instructions. So there is a piece of README that explains, at least on Linux side, what packages and how you need to install to actually make it compile and run. This is something we had challenges with. Ideally, I think like on Windows, it should just work. But if there is something for Windows or macOS, we'll add a section here as well, such that we ourselves, like a year from now, or others can actually install something and take advantage of this, because there are some packages we need to have in order to compile it. And then depending on GPU, you need to have some like drivers or some packages installed to actually run it. Otherwise, it will just not recognize GPU and we'll use CPU instead, which is not nice. So there are instructions for all of those. And I've also added them to CI. I removed some old operating systems and added OpenCL to the CI. So we actually linked and built everything going forward. We cannot run it because we don't have GPUs, but we can at least make sure it compiles without warnings. I think this is the brief overview of what's happening here. It matters anyway.
I have a question. So do we want to expose users utilizing GPU on the Subspace desktop? If so, we need to expose this notification from the library to the outside. I think that could be useful.
I think initially we will probably just use automatic mechanism that we have with Subspace codec. What we can do, we can actually do something like a function in this library which will say, I see AMD GPU or I see NVIDIA GPU.
Yeah.
And then we can use that and maybe compare somehow with the operating system. If you like see that there is NVIDIA GPU, but you don't see it through the library, then maybe you don't install the driver or something. And we can like prompt the user to do some actions depending on operating system and environment to actually make it compatible. That's something that matters to them.
At least it will prevent the confusion of like, am I using GPU or not for the end users for the plotting phase?
Yeah. Yeah, I think that's something that makes sense.
Yeah, it's definitely something we want to eventually support. I think we're going to have to do it step by step. So probably step one is making sure that it works, you know, in the terminal application, you know, and then like, does it work on Mac? Does it work on Windows? Does it work on Linux? Like, have we tested on different machines? Then after we like sort that out, then we'll maybe implement it like first on Windows in the desktop app, and then maybe try it on Mac, and then maybe on Linux, like try to like, you know, not try to do like one massive, like we'll solve it all at once, but like step by step and work out the bugs in the easiest way possible and like incrementally deploy it. So probably like when we launch incentivized testnet, we won't have GPU support on the desktop app, but definitely before mainnet launch, we'll have like across the board GPU support on desktop and terminal.
Yeah, it was just a future idea, not for this PR.
Yeah, it's a great question. I'm just trying to give you a little bit more clarity on how we're thinking about rolling that out.
Okay. There are some changes to Subspace Desktop. I think they're not very complex and relevant. So I think this is all for the core protocol.
I can't hear you, Nazar. Is it just me?
No, I can't hear him either.
Same for me.
Yeah, this thing is super annoying, just audio disappears sometimes. I was saying that we are almost at time. Unless anyone has anything else to add, we'll probably wrap it up.
I have a question. So for farming, in the protocol binary command, we have a huge code for running the farm. So farm function itself is a big chunk of a function, and it is not exposed from the library. So in the Subspace desktop, I also need to make changes or copy paste from the core protocol, copy the main farm function to the Subspace desktop and change it every time manually. So are we thinking on exposing this farm function as a compact thing so that Subspace desktop can use it, and when I upgrade the dependency from the cargo toml, it will just be updated? I can work on that either.
We can. However, there are several drawbacks. The farmer is designed in a way that has some CLI flags and stuff, and you configure it for a particular purpose. Not all of those purposes are relevant for the desktop application. For instance, it starts the WebSocket RPC server, which has no use in the desktop application, just like one of the examples. And it's not very difficult to assemble it. The other use case would be the Subspace codec. Like you can have freedom in the desktop application to enable or not enable some GPU or CPU support. Otherwise, it's just like a black box for you. Or we have to have a huge struct like in Substrate, which has a lot of tunables. So just don't see a huge benefit of exposing that, since you already have all of the pieces necessary and you have an example of how to put it together.
Yeah, it's not hard. It's not hard. It's just that 170 lines or something like that, copy pasting every time there is an upgrade to the core protocol, more manual workload. It could be more automated. That's why. But
okay, maybe we can expose some of the more. Well, I don't think it should be a lot of copy paste, but if there is, we can probably provide more functions for typical things.
I have an idea as a template. I can share it with you as a code list. Yeah, okay.
Yeah, another thing is right now we are connecting to the node over RPC connection. In the future, we will connect over channel in Rust.
Mm-hmm.
So the client implementation will the source of those notifications that the farmer receives from the node. The source will be different. It will no longer be RPC. It will no longer go through WebSockets, through serialization in JSON and everything like that. So you need to have lower level access to the implementation details to actually make use of it.
Okay.
Okay. Thanks, everyone. We are just in time. All those watching on YouTube, thanks for watching, and we'll see you in a week at the same time.